joint density function again. We'll start with discrete first, and y can have a values of 0, 1, and 2. And x can have a values of 0, 1, and 2. I can write x here if you want to. And I can write the probability of x comma y here. In case you missed it last time, let's say we have 0.05, 0.10, 0.20. For 1 we have 0.05, 0.15, and 0.05. And for 2 we have 0.25, and for 1 we have 0.10, and for 2 we have 0.05. We can find the marginal density function here, or probability function, x and the probability of x. And we can find y and the probability of y. Again, x can have a value, notice 0, 1, and 2. That's what x can have. When x is 0, what's the probability? Notice we don't care about y. When x is 0, so let's add these numbers. That's 0.3, 0.35. When x is 1, 5, 20, 25. When x is 2, 5, 15, and 25, is that a 40? And if you want to find the the average with respect to x is going to be 0 times 0.35 plus 1 times 0.25 plus 2 times 0.4. Well, might as well do everything I need right now. 0.25 plus 8, is that 1.05? I think that's 1.05. Let's look at y. Y can have also a value of 0, 1, and 2. For 0, we add 5, 10, and 25. That's 0.35. 10, 25, 35. 20, that's 0.30. The expected value of y is going to be the summation of y times p of y. 0 times 0.35 plus 1 times 0.35 plus 2 times 0.30, and I think that's 0.95. Now last time we said we're going to find what? To find the correlation, I need to find the covariance first. And what was the definition of covariance when we wrote it down there? So the covariance of x comma y, was it the summation of x times y times pxy minus mu x times mu y? Is that what we did last time? Was that the equation? The shortcut? Yeah. The expected value of xy. I might have wrote that actually, the expected value of xy minus mu x times mu y, or the expected value of x times the expected value of y. That's probably what I wrote last time. It's the same thing. So I know what this and that. I just did them. So let's find the answer to this one. Now this is going to be fun. But here's the good news. Because to do this is going to be to get this number is this times that, right? Add to it. For this is going to be this times that. Well, guess what? Mathematically, what will happen? Anyone that has a 0 in it, x0 or y0 will go where? 0 to 0. So instead of wasting my time multiplying these, I can just take my highlighter and say, you know what? When x is 0, all these are gone because this is going to be 1 times 0 times that number. That's 0. This is going to be 2 times 0 times that number. That's gone. Also, these are gone. Because y is 0. So I'm only going to do these 4 numbers. So why waste my time on the other ones? Just get to it quickly. So to get this number, x is 1, y is 1. 1 times 0.15. This one, 1 times 2 times 0.05. This number, 1 times 2 times 0.1. That one, which is what? 2 times 2 times 0.05. That's 0.15. 0.10. Is that 0.20? 4 times 5 is 20. 15, 25, and 40, 65. So what is my covariance? It's going to be 0.65 minus mu x, which is 1.05 times 0.95. It's negative 0.3475. Now to get the correlation, excuse me, it's the covariance of x comma y divided by what? Sigma x times sigma y. I need to find sigma x, I need to find sigma y. So how do we get sigma x? Sigma x is the summation with respect to x. How do you find sigma? Remember that from before, standard deviation. How do we get the standard deviation?
Square root of the sum of
X squared px minus what? Squared. Yep. So let me just find what sigma x and sigma y. I know what a mu x is. So here's sigma x. It's the square root of x squared times 0.35. 0 squared times 0.35 is 0. 1 squared times 0.25 plus 2 squared times 0.4. All of that minus 1.05 squared. Where's my calculator here? 0.25 plus, what's that, 1.6? 2 times 0.4. 4 times 0.4 is 1.6. 1.6 plus 2, 1.85. Minus 1.05 squared. Come on. There we go. Be nice to me now today. 1 point. Oh, God. Where's the calculator? F18. Okay. The square root of 1.85 minus 1.05 squared. I get sigma x to be 0.8645. Can I get sigma y? Square root of 0 squared times 0.35, that's 0. 1 times 0.35, that's 0.35. You square the 1, still 1. Square the 2, which is 4. 4 times 0.3. What's 4 times 0.3? Is that 1.2? Minus 0.95 squared. Square root of 1.55 minus 0.95 squared. The square root of 1.55 minus 0.95 squared. I got 0.8047. Did you get that number? So what is the correlation of x and y? It's negative. The covariance, what was my covariance? 0.3475 divided by sigma x times sigma y. .8046 times 0.8645. 0.3475 divided by that number. It looks like roughly negative 0.769. So we have a negative correlation. I wouldn't say strong, but it's between moderate and strong, like medium and strong correlation. 1 is really strong, 5, 6 is medium. It's a little bit more than medium correlation, negative correlation. When one increases, the other one will decrease. I know I went through it quickly, trying to get out, because I only have 10 more minutes to do now with continuous. We're going to repeat the process with integrations. So I'm going to cheat here and just give you the equations. I'm not going to go on my calculator and try to integrate them. Hopefully you can integrate. So let me take an example. But you saw that now, hopefully it makes sense when we get to the continuous. My function I'm going to use, again, I don't have a story for you. I can make a story like this is supposed to be this or that. Eight xy I think we did that problem. What was it? X between 0 and 1, y between 0 and 1, and x plus y is less than 1, I think. Was it? I think. And 0 otherwise. And we're going to find the correlation for that one. Just like the other one, just like we did the discrete, I need to know what f of x, x, and f of y, y. That's px and py. So what is f of x, x? It's the integral with respect to y. And y is going from 0, notice, to 1 minus x. From that one. And if you clean that one, if you go through it and integrate it, this happens to be, I'll just put the answer, 4x cubed. And x goes between 0 and 1. And to find f of y, what's the area? 0 to 1? Oh, sorry, my mistake. This was not the equation. This was y equals to x. I think the one we did last time is a different function. So we're talking about we in this area.
So then the limits would just be 0 to 1?
Yep. Well, it wouldn't be 0 to 1. Notice we integrate with respect to x.
Oh, 0 to x.
For the x value, x goes from 0 to 1. I wish they gave us that equation. I'm looking for that. Where is the area? I'm just looking to see where that area. When you do with respect to y, you're going from 0 to where? To x. Now, f of y, you integrate with respect to x. This will be from where to where? It wouldn't be from 0. It wouldn't be from 0.
Different one.
It will go from here, notice, to there, right? Each piece, right? So you actually go from that x value here. And that x value happens to be what? The y value. So this will be from y to 1. Because you're not starting from 0. You're starting from this one to get that piece there with respect to what? We're doing with respect to x now? Oh, with respect, yeah, to f of x, yep. And when you simplify this, your limits are different. There's a 1 here. That changes your answer to 4y minus 4y cubed. And y between 0 and 1. But you're still going to be in this area. They want you to be in that region. Y equals to x. So with respect to y, you're going from here to there. And that's really y, and y happens to be x. So from 0 to x. And this one, you're going from here, which is x to 1. And x happens to be y, so from y to 1. That's your limit. So those are your function. F of x, f of y. This is actually finding these two. Next, I got to find mu x and mu y. Well, how do you find mu x? Mu x, it's the integral of x times what? F of x. And we're saying now, the way my restriction says x is going from 0 to 1 for f of x. So that would be the integral from 0 to 1. And this will be 8 or 4, x cubed. So when you multiply it by x, that would be 4x to the 4th. Four x to the 5th divided by 5. When x is 1, that's 4 over 5. He's saying, why didn't you go from 0 to x? I already took care of that. right here I'm saying x goes from 0 to 1, but I already took care of y, where y is going from where to where. And x is going from where to where. I took care of that right here. What's mu y? It's the integral from 0 to 1 of y times g sub y. And if we do the math, that's what 8 over 15. Now to get the covariance, I need what? Mu xy, or expected value of xy. Because the covariance equals the expected value of xy minus the expected value of x times the expected value of y. The expected value is really mu xy minus mu x times mu y. I have these two. I got them right there. I need to get mu xy. What's mu xy? That's the integral, double integral here. X is going to go from 0 to 1. You can do that. If you want to do x first, y second, it's up to you. Which one you want to do first? X goes from 0 to 1. The y value goes from where to where? Y goes from here to there. 0 to x, correct. 8xy dy dx. And I'm going to cheat. I'm going to assume you all can integrate. The answer is 4 9s. You can go to I-89, type it in. It gives you 4 over 9.
It's all based on the same thing.
Do we know what the covariance is now? It's 4 over 9 minus mu x, which is, where is it? 4 over 5 times 8 over 15. Yes.
So, when you were solving for fx of x, where did the xy come from again?
The xy, 8xy?
Yeah.
That's the function. F of xy is 8xy. Yep. So now we get the covariance. So what do we have left to do?
We need to find our,
Sigma x and sigma y. Let's get sigma x, let's get sigma y. Sigma x is the square root, so if I do sigma x squared, then I'll take the square root after that. It is the integral, negative, we'll change the limit, negative infinity to infinity of x squared f of x, just like we did the other one. F of x, we have the expression for it. We just did that. It goes from 0 to 1. So here we go, 0 to 1, 4x cubed times x squared. Dx minus mu x, which I calculated that to be 4 over 5, and you squared it. God, I hate that. Integrate that, plug in the limits, and sigma x squared. We'll take the square root after that. If I put the square root, it will look really ugly. Sigma x squared will be what? 0.049 roughly, which means sigma x is the square root of 0.049. Clear. What do we get? 0.221. And let's find sigma y. So sigma y squared equals the integral from negative infinity to infinity, y squared times f of y dy minus mu y squared. The y value again goes from 0 to 1. What is it? We find f of y from 0 to 1, and what is it? Right here, 4y minus 4y cubed. And what was mu y? 8 over 15 squared. I think the first number is wrong. That's not 0.04. I think that's the y one. Sigma x actually squared. God. A little bit off there. Double check your numbers. Sigma at 0.0266 or 0267. Just change, go to the calculator and plug them in. The square root 0.0267. That's 0.163. So I get sigma x, I get sigma y, I get the covariance. What's the last step? Correlation. What is the correlation of x comma y? It's the covariance of x comma y over sigma x times sigma y. I have sigma x, sigma y right there on that page. Let me put them in while I have in front of me. Oh, God. That's the squared. It's right here, 0.163. .221. And what is the covariance? 0.01778, right? Do the math, and that's our correlation. If I push the right button, I'm getting roughly 0.5. A weak positive correlation. Not a strong correlation, a weak correlation. Positive says if one increases, there's a 40% chance, 50% chance the other one might increase, you know.